Hello class, AQR, Mr. Solis again, and today we're going to be, in this tutorial, we're going to be talking about growth models, or what I like to call the zombie apocalypse. Ooh. So right here, we have this case where we have H1N1, and it's spreading to a population of 100 people. And we want to go ahead and map out that spread. So how do we do that? Well, we have something called a hundreds chart. So we have this chart, it's a 10 by 10 chart, and it represents 100 people. And patient 0 is our originally infected person. This is the person that started with the infection and they started with everything. So this is how we're going to be working this during the class. We're actually going to be doing this in class. I'm going to show you some numbers, but you're going to go ahead and come up with your own, using with your own calculators and everything. And we're going to be using this chart in conjunction with that hundreds chart. This basically goes ahead and maps out our days, the number of initially infected people on that day, the number of people who get infected, and then the total number of people infected on that day. And then I'll go ahead and just go to the next one. So right here, initially we had no people infected. This is with no people. And in patient 0, he gets infected or she gets infected. So that's one newly infected person. 0 plus 1 is going to give us this one right here. Now, what we do is when we do this number, we go ahead and take it and we put it at the beginning of the next day. It's sort of recursive. So we start out with that person, then this person infects someone else. More than likely, he's going to infect one other person. Plus, so we have 1 plus 1, and that's equal to 2. And we'll just move on from there. Now, there's a couple of rules I need to make sure we understand. Number one, original person is going to start infecting people. Uh, if someone's infected already, they cannot reinfect someone. If someone's already a zombie, they cannot become a zombie again. You can get double zombies. Then we get into some strange lore about zombies making zombies, or does a zombie turn into a human? We don't want to talk about that. Basically, if somebody's already a zombie, they stay a zombie and they never get cured. Once a person's infected, they cannot infect themselves or a person that's already infected. We can only infect new people. So we go to this chart. I have the hundreds chart on the left, and I have a whole chart in front of me, so that way I can go ahead and do everything together. You're probably wondering, how am I going to do this? Well, I'm going to use a command on my calculator called random or randint. This stands for random integer, and I'm going to be choosing numbers from 0 to 99. And that's how I do my random int. So here's my calculator. Where I can get random int, I can just go ahead and do that through the math key, which you should be able to see the mouse moving. And I click on the math key and it brings up this. And I want to go ahead and look at this right here. PRB stands for probability. You can already see rand as the first one, but we don't want that. We want random int. So we want selection number 5. Click that. Now we just go ahead and type in 0, comma is this button above 7, just in case you didn't know, comma, 99, and then close the parentheses. Now once it's entered, we don't have to enter it anymore. So I'm going to push enter once, and it spits out 14. So this is how this works. Like we said, we didn't have anybody originally infected. 0 plus 1 is equal to 1, and we take that 1 and put it over here. Now we're infecting person number 14. So now we have one other person right here, and then we're going to go ahead and add these two numbers together. And that person was 14. I'm writing it there just to go ahead and keep track of the people that we infect on this particular thing. Now we have 2 people. You're probably wondering, well, what the heck are we going to do, sir? Well, I'm going to clear this page so that way I can start afresh. I'm still just going to hit enter. I'm going to hit enter twice. So 51 and 40 get infected. So So we go ahead and go to the numbers chart, take off 40 and 51. Those people are now infected, so we have 2 people. So we're going to add these 2 together, so now we got 4. Now I have 4 over here. Clear again. 1, 2, 3, 4. So 73, 4, 33. 73, 4, 33. Who else? And 99. The very last person in town. So that's another 4 people. So that's a total of 8. I'm going to take these people off of the numbers chart. So that was 73, 4, 33, and 99. And these people can no longer get infected. So now we have 8. Go back over here. 1, 2, 3, 4. I'm going to do it 4 at a time. So I got the first 4 people. 20, 79, 95. 75. Oh, that was 79. Sorry. 79, 22. So this is 79 and 22. You might want to start copying these numbers on a separate piece of paper because this is going to fill up really, really fast. So another 4. 1, 2, 3, 4. So as you can see, we already had 0 infected, so 0 can't get reinfected. Let's see, so let's see, 36, 0. 9310. So let's see. Well, let's see. 20 is newly infected. 95 is newly infected. 79 newly infected. 22. 36. 0. We don't take off 0 again because zeros are infected, so 0 doesn't get infected. 93 and then 10. So what that means is we have not 8 people who got infected, but 7. 7 plus 8, 15. So now we have 15. Then we move to the next one. But you get the idea. I want you to, you're going to be completing this chart inside the class for 15 days. This will get a lot of stuff, and like you can see, it's starting to grow a lot. You're going to need a separate sheet of paper for this, so you can go ahead and take down the numbers for the people that are getting infected. And we're going to be answering questions like, how is the number of infected people growing? What function would you use to model? Also make a scatter plot from this. Determine the record model that best fits this. What are the dependent variables? Graph the function scatter plot. And you might have to use one of the regressions. Maybe either line reg, linear regression, exponential regression. You can never know. Use a regression equation to predict the number of infected people by day 10. And what's your conclusions? Add 7 and 9 to the simulated data and all that fun stuff. So we're going to be doing this. So any questions? Well, wait a minute. Why am I asking you? You can't even answer back. I'll see you in class. And remember, this is the zombie apocalypse. And we're going to be mapping their infection.